3CX phone system can use the internet to connect to remote extensions, VoIP providers, and bridges with other 3CX phone system installations. For correct functionality, we need to ensure that the connection can happen, and we also need to ensure that enough bandwidth is reserved for the communication to suffer as little packet delay or packet loss as possible. When the 3CX phone system needs to communicate over the internet, it will typically do this across a border device, which will be a WAN to LAN device, which also typically has firewall or NAT functionality. This is especially true when the organization has insufficient public IP addresses to dedicate a single public IP address entirely to a 3CX phone system. A firewall may drop or reject certain traffic, and the NAT device will very often translate source or destination port numbers, with the result typically being call delivery with missing or one-way audio, difficulties with hold and resume functionality, and sometimes difficulties with transfer functionality. 3CX strongly recommends using port forwarding features on the border device to direct all 3CX related traffic to the machine running 3CX phone system. Keep in mind that configurations where port forwarding is not correctly implemented or not functioning correctly are not supported, and will severely limit the possibilities to resolve certain issues. 3CX phone system will, by default, use the standard SIP UDP port, which is 5060, for signaling, which is basically used to set up calls, terminate calls, hold and resume, and transfer calls from one extension to another. Remember that changing the default SIP port from 5060 to some other port number will immediately eliminate almost completely the possibility to use SIP trunk services provided by some VoIP providers. By default, 3CX phone system will allocate the range of UDP ports between 9000 and 9049 for sending and receiving audio streams, which is the call audio itself. This allows up to 25 simultaneous calls over the internet connection, so this range also needs to be port forwarded to the 3CX phone system machine. This range can be safely adjusted to some other range, and you can also widen it if you need to deliver more than 25 simultaneous calls, bandwidth permitting. To assist with remote extensions and bridges, 3CX phone system also includes a proprietary tunnel protocol that listens on both UDP and TCP port number 5090. Successful use of the tunnel protocol will require setting up port forwarding also for UDP port 5090 and TCP port 5090. The Firewall Checker is a valuable tool to ensure that port forwarding settings have been implemented correctly on your firewall or NAT device. First, stop the 3CX phone system and the 3CX phone system SIP and RTP tunneling proxy service. Next, from the Settings Firewall Checker page, click the Run Firewall Checker button. And if the output of the firewall checker mentions any warnings or errors, you will need to review your port forwarding settings on your firewall or NAT device. VoIP providers will not work correctly if this test does not pass without warnings or errors. Missing or one-way audio is one sure way to identify that you have firewall configuration issues. If the internet connection is being shared for VoIP and also for other internet traffic, such as mail or browsing or FTP downloads, voice quality can be severely degraded. As a quick example, let's say that the PBX is currently handling 5 calls over your VoIP provider accounts. Your bandwidth is definitely sufficient to handle this volume of calls, and for a while everything progresses normally. Now, some other user on your LAN is browsing the web and decides to download a large PDF document of 80 MB in size. What happens now? Well, very simply, the VoIP calls and the PDF download will compete for bandwidth. If the download cannot get all the bandwidth it requests, it will simply take longer to download. But if a VoIP call cannot get all the bandwidth it needs, you will get broken audio, as your packets will arrive too late for the PBX buffer to compensate. This broken audio issue will be visible on all the calls happening at that time over the internet connection. QoS, which stands for Quality of Service, can be implemented on the router. You can categorize the different types of traffic according to custom rules and then assign a higher priority to VoIP traffic categories. One way to achieve this is to use the port forwarding information to build traffic type based QoS rules. So, as we have in this example, you would prioritize all traffic from and to UDP port 5060, UDP port 5090, and TCP port 5090, and also the range 9000 to 9049 in UDP. Another method available in some devices is to prioritize all traffic to a particular machine, which could be identified by IP address or MAC address, or, like in the example we have here, by the physical port on the device.